this is Jo from Maths Tutor Me. Today we're doing a topic called circles and cylinders, and we're looking at the area of a sector today. In the last lesson that I did, we learned how to find the area of a circle, and now we just want to find just the little sector, the little cutout part of the circle. Now if you remember also from when we did arc length, because this formula is very similar, we put the angle of the sector that we have over 360, but instead of multiplying it by the circumference formula like we did for arc length, when we're doing area, we want to multiply it by our area of a circle formula, the pi r squared. So here's our new formula, theta over 360 times by pi r squared, where theta is the size of the angle at the center. Okay, so if I want to find the area of this sector, all I have to do is take the angle that I've been given, the 136, put it over 360 degrees, and times by pi r squared. Pi times by the radius, which is 8.2 squared. Okay, that's equal to, let's find out, 136 over 360 times by pi times 8.2 squared. And we're asked to do this to two decimal places. So 79.80 centimeters squared. Okay, and that's found the area of that sector. So let's look at B. Let's do it again. Find the area. All we have to do is take the angle, which is 60 degrees, put it over 360, and we times by our area of a circle formula. Pi times by the radius squared. Type it in. 60 over 360 times pi times radius squared is 63.36 meters squared. Okay, in question 2, find the area of the shaded region in terms of pi. So to find the area, we'll stick with our formula. The angle, it's 90 degrees outside here. That means we're going to have 360 the whole way around. Take away the 90 would give us 270 degrees inside my sector. Okay, so 270 degrees is what I have. I want to divide that by 360, and I want to times it by pi r squared. Pi times by my radius, which is 17 squared. Now the thing that is different about this question from question 1 over here is that we're asked to leave our answer in terms of pi. It means I don't want to go down and get this decimal answer that we're always getting decimals whenever we put pi in our calculator. What we want to do is we want to calculate all the rest of these numbers here and leave the pi sitting at the end. So what I do is I type in everything else, so 260 over 360. Don't type the pi in, just times that by 17 squared. Okay, we want to leave it in terms of pi. That's going to give me a decimal, so we'll leave it as an improper fraction. So what I have is 867 over 4, but I didn't use this pi here, so I just sit him here at the end. So 867 pi over 4 would be an exact calculation of this shaded area here that has not been rounded. It's still in millimeters squared though, so I have to remember to include that. Alright, question 3. If a sector with a center of 42 degrees is cut from a circle with a diameter of 9 meters, find the area of a circle that is remaining. So I have a circle. I have an angle of 42 degrees in the middle. So just roughly drawing a little sketch here. Let's go about there. That's 42 degrees. It says that my diameter is 9 meters. That's a bit of a trick, isn't it? So these are actually the radius that I've drawn here. So let's put down 4.5 for the radius. Find the area of the circle that is remaining. So we don't actually want this little bit, we want this whole big bit around the outside. Okay, so the area of that sector, I need to know this angle around here. Now there's 360 degrees the whole way around a circle, so if I take 360 and I subtract off the 42, that means I want 318 degrees. So 318 degrees over 360 times by, because we're finding the area of this sector here, pi times by the radius, which was 4.5 squared. So typing it in, 318 over 360 times by pi times 4.5 squared is 56 point, let's do one decimal place here, 2 meters squared. That's it for that question. So in order to become good at something, you need to practice. So here is some questions for you to try to see if you can remember what we've just learnt. So pause the video and try these questions and restart for the answers. So question 1, find the area of each sector correct to the nearest whole number. So to find the area of a sector, we take the angle that we're given, we put it over 360 degrees and we times by pi r squared. Pi times by, our radius is 16 squared. So in the calculator, hopefully you got. Now to the nearest whole number, we have to round that 5 up into here to be 101 centimeters squared. For B, same thing again, finding the area. Our angle this time is a tiny little 10 degrees over 360 times by pi times radius squared. So 10 over 360 times pi times radius squared. To the nearest whole number would just be 16 meters squared. For question 2, find the area of this sector in terms of pi. So the 40 degrees is cut out of my sector, so I have to take away 40 degrees from 360 degrees, which would tell me that this is 320 degrees in here. So the area is 320 over 360 times by pi times by radius. Well, that's also a bit of a trick. 45 is the whole way across, that's the diameter. So half of that for the radius will be 22.5. So 22.5 squared. Okay, so to leave it in terms of pi, we calculate these numbers leaving the pi out of it. So 320 over 360 times by 22.5 squared, which comes out a very nice 450. And then we just slot our pi on the end. And don't forget your units, centimeters squared. And last of all, question 3. The beam from a lighthouse reaches a distance of 9 kilometers and spreads to an angle of 35 degrees. Find the area covered by light correct to one decimal place. So as a diagram, it hasn't given us a diagram, it's always good to draw one. I have a light beam shining out and it makes an angle of 35 degrees. My light shining between there and it goes 9 kilometers out into the ocean. So I want to find the area that is covered by light to one decimal place. So area of that sector is 35 degrees out of 360 degrees times by pi r, which is 9 squared. In the calculator, 35 over 360 times pi times 9 squared equals, to one decimal place, 24.7 kilometers squared. And that's it. Hopefully you got those answers. So keep practicing, practice as much as you can, and I'll see you next time.